Hi, this is Rich again, talking to you about tool steels, carbon, and alloys. First off, let's talk about tool steels in general. It's a category, it's a flavor of steel. When they're molding steel, they put a lot of different components, a lot of chemicals in it that make certain steels better for some applications than others. And you're getting tool steel from your vendor typically. It is in the annealed state, and annealed, anytime you do that, the definition is in its softest form. In other words, you apply heat to these steels, you're changing the molecular composition of those steels. And if there's carbon in there, and there's always carbon in there, it's just how much, that carbon heats up and that changes the hardness. And so consequently, you're making a chemical change within that steel. The most common type of tool steel is A2. A would stand for air hardening type of grade. And when you're buying tool steel from TMS, this material is going to come to you typically oversized, 15 to 20 thousandths. What that does is, let's say that you're, as a customer, you want a block of steel that's 2" by 2" by 6 inches long, and you want, let's say, D2 tool steel material because you're going to make a knife. D2 has got a lot of chromium in it, and a lot of moly, so consequently that's what knife makers lean towards. Get this material in, this block of steel, and it's not 2" by 2". It's 2.015 to 2.030 typically. It's a little oversized. And then what they do is, while it's annealed in its softest state, they can drill holes, they can tap those holes, they can manipulate that steel, slice into it, cut it, do whatever they want to do with this material, but it's not ready for them to use in their tool. What they do at that point in time is, once they machine this thing and made it pretty and right, they will put it through a heat treating process. So let's say it goes to 1,000 degrees and you're going to bake this material for 10 minutes. When you bake it, you change that molecular structure. Now you've hardened this thing, and you've got finished product. It will come out with a little bit of scale. It'll look dark. It'll look burnt a little bit. That's what that extra oversize is all about. Now they can grind it, surface grind it down to exact dimensions of whatever this tool has to be. You would have A2, D2, O1, S7, P20, M42, M2, it goes on and on and on. All the different tool steels that you could get, but they're all specific for certain applications. And they know what they want, they've been doing it for a while. Next category outside of tool steels would be high carbon material. It's an alloy type of a steel. Let's say somebody calls out, they want 8620, 4140. The last 2 digits of those 4-digit numbers tell you how many points of carbon are in that material. And again, carbon's key. When you get into some of this material, and again, it's pretty soft, it's annealed, you can tap holes and do whatever you want to do with that kind of thing. Those points of carbon are real specific as to how hard you can make that tool. A lot of our people in the local area, machine shops and such, use something called brick die. It's an old term that everybody uses. Typically, it's 4140, 4150. It's got those 40 to 50 points of carbon in there. But when you call out brick die, that means you want it already heat treated. This thing's heat treated to 28 to 32 Rockwell, and for many applications, that's hard enough for what they want to use that in piece for. There's a lot more to this, but to keep this thing short and give you a little brief idea about tool steels, carbons, and alloys, we could go on and on. So many different directions with this, but this should get the party started, let's say.